Okay, so I've been searching through lots of tubes trying to find a replacement for the other one of these, the 6AM8, and I haven't found one. And I'm thinking I probably don't have one. So what am I going to do with one tube? I'm thinking, let's transfer this tube to the other channel, run the amp, and see if the other speaker makes sound. Problem is, I'd be running this with one tube out. I don't think it's a concern. A lot of the tubes here are 6-volt tubes. It's got a big transformer, no doubt a 6-volt supply, so I think everything's in parallel. Pulling out a tube really shouldn't cause any problems with it. So why don't we give that a try? What I'll do is I'll transfer this tube over now, and we'll fire up the set and see what we hear, if anything. And, okay, we're on. Make sure everything is nice and safe and secure here. Good enough. Okay. If you remember, we were having volume control problems with this set. The volume will go down to 0. So there's definitely some more stuff to figure out on here. Okay, tubes are just starting to conduct. Okay, let's see what we hear. Well, we hear a little something. And it's out of the other speaker. So let me get the bad tube and we'll stick that back in. And I'm watching for it to heat up. Doesn't seem to be heating up. There, now close like this. Let's see what we see here. Okay, well, you see this tube lit up quite clearly. This guy, there's nothing in him. He's dead. He's dead, Jim. Yeah, so there's no question this tube's bad. So, okay, so that kind of resolves the nature of the one channel problem. Now, there could be a secondary problem. This tube might be dead because of something going on with the circuitry feeding this socket. And maybe driving this tube, sorry about that, maybe driving this tube hard. But we'll check a few voltages underneath here. But in any case, this tube's definitely dead. I need another one. We can carry on with the radio work and see where we get with it. We can carry on doing some voltage tests on these tubes, making sure grids aren't being charged positive and stuff like that. Okay, let's hear what it sounds like. That's AM. This is the FM side. Not tuning right at all. There's still something more going on with the FM side of this receiver. And of course this tube won't have any effect on that, it's an output tube. So I think that's what we need to do, is some voltage testing. So let's set up. Okay, so we're all set to check some voltages on the pins of the tubes in the receiver and in the amplifier. We're going to start with the amplifier. And it's always wise to do this. And verify that there isn't some unfortunate voltage problems on tubes. Most importantly, positive voltage on the grid of an output tube. And another one is failure of the capacitor that bypasses the cathode resistor. And these two things need to be checked. And that's what we're going to do here. Now, the output tubes are 6 AM8s. And according to my tube manual, you shouldn't even find these in a radio. And oddly enough, it's a two-part tube, and one part is a pentode, and the other part is a diode. And why you would have this tube in the output? I'm a little confused about why they would use this particular tube. Now, it's a big tube, so it's going to have some power to it. But I have the feeling it was really designed for use in televisions. It says right here, as a IF amplifier, video amplifier, or AGC amplifier. And the diode is used as an audio detector, video detector, or DC restorer. I don't know what a DC restorer is. So, mystery as to why they chose these particular tubes. But nevertheless, we still have the ability to check them. That's not an issue here. So let's see, the grid should be pin number 2 on the output tube. And I think it's a 9-pin, yeah, 9 pins on this thing. Okay. So let me, I'm going to clip my negative lead on my voltmeter just to the chassis here. Let's see, our meter is set for DC plus 500 volts. That's pretty high for the grid, but let's start there anyway. So now, so this is pin number 1. This would be pin number 2 here. Ooh, that doesn't look right. That looks like a cathode resistor right there. Here, let me give you a little better seat here if I can do it. Hang on. A little bit of noise here. Ooh, ooh, ooh. Now, if I can get tricky enough, I should be able to get a magnifier in front of that. Let's just see how this goes. Yeah, it's not bad. I can go a little closer. Okay, that'll have to do for now. Oh, you can't see the voltmeter now, can you? Phooey on that. You need to see the voltmeter, so let's take that away. Bad idea. Back you up. Get you around the corner here. There's the voltmeter. A little bit further. Okay, so we'll switch on the set. Now it's all safe. Still has speakers connected. Okay. Switch is on. Let's get this light somewhere where we can see it. There we go. I put the light up on top here so I can see it, because I really need to be reminded that this thing is on. More than once I've walked out of my shop intending to come back, and then I don't come back for other reasons. Later, 5 hours later, I come back in the shop, and here I've left everything on, so I don't I don't want to do that kind of stuff. Because as you know, my cat Draper likes to come in here and investigate things. And I'm sure he does that at times when I'm alone. So plate current's flowing. We'll give it the full treatment there. Gonna be about 125 volts. Now, why is pin 2 not the grid? Pin 1 is the cathode. Pin 1 should have a cathode resistor on it if that's what they're doing with these output tubes. Wow, I don't know. It's not making sense to me at all. Let's poke around with some voltage readings here. See what we get. Okay. The socket with the operating tube is this one. This is pin 1. Well, that sure sounds like the grid operating, doesn't it? Doesn't seem to match the pin layout in the book. Pin 1. Pin 2 is a tiny positive voltage on it. That would be what you would think is the cathode. Pin 3 is nothing. Pin 4 nothing, but they're going to ground right there. Lost count. 1, 2, 3, 4. Pin number 5 also being brought to ground by that resistor. Pin number 6. There's a little bit of voltage there. So pin number 6 has all of 175, 180 volts on it. This guy's got about 100 volts on it. That's probably a screen. Nothing there. Small positive voltage there. Then this is a pin of nothing. There's no pin there. What about the other tube? We'll repeat the same thing. Here's the high voltage. Same voltage. That's also got the lesser high voltage. That's a little higher. That's the second pin. That's this pin. What's going on there? That would be pin 9, pin 8. Pin 9, pin 8. Well, that's quite a difference. Now this one has the operating tube in it. Pin 9 and 8. That resistor looks burned. Well, according to this, there's something funny going on here. Pin, what did I say? 9 and 8? Pin 9. Pin 9 as a suppressor. Pin 8. Pin 8 is the plate on the diode. I don't even know why they would even have it connected. What can a diode do for you in the output circuit like this? You got me, but there's definitely some funny voltage stuff going on here. And let's just compare those again. Tube to tube. So this is pin 1. And this is pin 1. My meter right on 0 there. Pin 1, no DC volts. pin 1 down below. Same thing. Pin 2, nothing. Pin 2, nothing. Pin 3 and 4, nothing. Pin 3 and 4, nothing. 1, 2, 3, 4, 5 and 6. 5 and 6. 6 is 175 on my meter. 175, very same. Next pin, about 90 volts. Next pin, 90 volts. And then we've got nothing, and something, and something. And we got a little something there. So this is pin number 9. Almost the same. Pin number 8 is different. Well, they're wired the same. No sign of heating in the resistor to ground on the other tube. There's a sign here. You know what? This is going straight to the output. Wait a minute, it can't be. Can't be. Isn't it? Doesn't have to go through these output transformers. What's going on here? So this, what is this pin anyway? This is 9, pin number 8. What's going on with pin number 8? Ooh, number 8 is the 8. Did I look at this wrong before? Pin number 8. It's a little tricky to see it. Is the diode plate. Who cares about that? Am I doing something really stupid here? This is a 6AM8. Six BM8. I am doing something stupid all this time. Oh my god. I don't know how many of you caught that. How long will it take Jim to figure out his mistake? That's really what these videos are about sometimes, you know? Just... oh, man. 6BM8. Now, a wiser man might say, well, I'm not showing anybody that video. Guess what? There is no 6BM8 in my book. Certainly explains the funny readings, though. Okay, I gotta go find myself some info on a 6BM8. 6. You know what I'm gonna do? I'm gonna write this on a big piece of paper and stick it on here, so I can't wander off. Boy, my mind really does wander badly, doesn't it, when it comes to these numbers? 6BM8. So let me go find the pinout for a 6BM8. Okay, so I did a little more research on the 6BM8. I say very purposefully. I found this diagram. Where are you? Down here. I found this diagram. It's not the best way to look at a tube, but it's going to show me the layout. And sure enough, look, it's not a diode pentode. It's really a pentode triode. And that makes a lot more sense because you can utilize the triode. Well, I don't know which one actually they would use for the output. They might use the triode on the output side. I'm not sure. Let's see, power max 1 watt, and power max here 7 watts. So 7 watts. So something's going to produce 7 watts. I'm not sure which side of the tube this is. I'll just use the diagram here. That'll help me with what I want to do. which is check voltages. Okay, so now if we start at pin number 1, we see pin number 1 is a grid. Pin number 1. Pin number 1. And that's why you hear that sound. So now we also know this is the triode side. Pin number 2 is a cathode. That explains the big resistor here. Somewhere there should be a fairly large bypass capacitor here too. Oh, I don't see one. Well, maybe they're not bypassing the cathode resistor. And there's a tiny positive voltage there. Let's see how much it really is. Okay, so you see on this one it's going to be 15 volts, around about 4 volts. And on the other one, you'll probably see nothing because there's no tube in the socket conducting. So there's no drop on the cathode resistor on the other one. So we'll just continue on with this one here. The next pin in our pin parade here would be 1, 2, 3. 3 is grid on the other. So that's one grid, that's the other grid. And you can hear a little bit of static when I touch it. And you know what? There's a slight positive voltage on that grid. On the other grid is a slight negative voltage. What you really want. This one's got a slight positive. How's that compare down here? Whoa! Oh, okay. Okay, sorry. I had to just suddenly disappear there and go answer the telephone. So where were we? So we were looking at this chart and we were just finding a voltage which was kind of throwing me right off. Let's take another look at that. We were looking at I can't remember now what it was. Was it 3? Something. Oh, we were over here getting a big positive on one, but not the other. And that would be pin number 1. It'd be pin number 3. 1, 2, 3. Pin number 3 is a grid. That's not good at all. I shouldn't see a grid going positive like that. It's going positive about 10 volts. The other grid, if it's positive, it's just a tiny bit positive. Now there's a blocking capacitor right here, blocking this high voltage. It's not that high. 40 volts from reaching this pin. Just look at that. That's way more than 40 volts there. And this could be because I don't have a tube, working tube in the circuit. But I don't think this one can be caused by anything other than bad capacitor right there. Sorry, right there. So we'll change out these two capacitors. And now oddly enough, the circuit with the defective tube is the one that reads the high voltage, but the defective tube I swapped. So the good tube is in the socket, was in the socket with this high positive voltage. You kind of think the wrong tube is burned out here, in other words. Well, let's keep going around. Pin number 7. Let's look at pin number 1, 2, 3, 4, 5, 6, here's 7. See the meter jumping over there. And we should see the same thing here. Yeah. And this, I believe, is the plate. It's really good. And then we're seeing on pin number 8, 40 there. Yeah, there's definitely something out of sorts here. So we have a couple capacitors to change out first. We'll shut the set off, and that's what we'll attend to. Change out these two capacitors right here. Well, this one seems to be leaking. This one will probably leak later, or it's leaking slightly already. So we'll get rid of those.